Okay, hi everybody, this is the Math 31 optimization review. This is question 12. Okay, a printed page is to contain an area of 432 centimeters squared of actual printed material. And then there's going to be a margin on either side, that's 4 centimeters, and then a margin top and bottom. So let's just kind of diagram this out to get a sense of what's going on here. Now if it looks like I've done this before, it's because I did. Initially, I chose a method that was maybe a little bit more awkward here. It's just a matter of placing the variables. In this case right here, in the previous time I did this, I put the x here and the y here, but I think we're going to put the x here and the y here. I think this will make this just a little bit easier for us to work with. Okay, so we know right now that 432 is going to be xy. Now what we are looking to do here though is to minimize the area of the whole thing. Okay, we're going to be printing stuff here, but we're going to minimize the area of the whole thing here. So the area of the whole thing is going to be, well, this is x, but we've got a border of 4 on either side. So that's going to be x plus 8. Okay, and then y here, but the length of the whole thing will be, remembering that there's a border of 3 on top and bottom, y plus 6. Okay. Now, come back down here, and we recognize that 432 is x times y. Let's just solve for one of those variables, and I think most people prefer to solve for y, so it'll be 432 times x. Sorry, divided by x. And so this will be x plus 8 times 432 over x plus 6. And you know, this might not be a bad place to expand this all out. When you multiply those first two terms together, sorry, you can hardly see that, that'll be 432 plus 6x plus, okay, well, 432 times 8, I don't want to do that. Looking at it, so 3, 4, 5, 6, oh, I love that answer, over x plus, and then 48. Okay, now let's take the derivative. Okay, the derivative with respect to x, this is a wonderful derivative. It's going to be 6. Now notice that the two constants are going to disappear. Minus 3, 4, 5, 6 all over x squared, which is great. This is an optimization problem, so I will set the derivative equal to 0. Okay, and I'll solve. So 6 is equal to 3, 4, 5, 6 over x squared. So 6x squared is equal to 3, 4, 5, 6. Okay, so we'll divide that by 6. X squared is equal to 576. Sorry, I want to move this paper up here a little bit. And let's take the square root of that. And I'm not entirely sure that's going to work out nicely. Oh, and it does. Isn't that wonderful? X is equal to 24. Okay, now that could be plus or minus 24, but the truth is, because we're talking about the dimensions here, it's got to be positive 24. Okay, so what should the dimensions of the page be? Well, okay, if x is 24, I can come over to my 432 divided by x to get y, and I will get that y is equal to 18, which means if I think about the dimensions of my piece of paper here, my dimensions were x plus 8 and y plus 6. Oh, you can't see that. X plus 8 and y plus 6. So 24 plus 8, so 32 centimeters, and then 18 plus 6, 24 centimeters. So these are the dimensions of the that will minimize the amount of paper being used.